The first sorting algorithm we're going to talk about is bubble sort, which is the simplest of all sorting algorithms. Let's say we have an array of integers, and we want to sort this array in increasing order. With bubble sort algorithm, we scan the array from left to right, and if items are out of order, we swap them. So we start off by comparing the items at index 0 and 1. If the right item is smaller than the left item, we swap them because we want to sort this array in ascending order. So here, 2 is smaller than 8, and we have to swap them. Now we compare the items at index 1 and 2. Again, the right item is smaller, so we have to swap these items as well. One more time. Again, we have to swap these items. And one last time. Okay, this was our first iteration or first pass. We need multiple passes to fully sort this array. At the end of each pass, the next largest item moves to its correct position. So here 8 is in the correct position. This is why we call this algorithm bubble sort, because after each pass, the next largest item bubbles up and moves to its correct position. So in the next pass, the next largest item, which is 4, will bubble up. Let me show you. Once again, we compare the items at index 0 and 1. These items are in the right order because 4 is greater than 2. So we don't need to swap them. Let's look at the next two items. 1 is smaller than 4, so we should swap these items. And one more time. Again, these items are out of order, so we need to swap them. And the last two items. These items are in the right order, so we're done with the second pass. Now, 4 is in the right position. As you can see, our array is almost sorted. We just need one more pass to swap 2 and 1, and then our array will be fully sorted. So let's do that real quick. All right, our array is fully sorted. Now let's talk about time complexity. If you're not familiar with this concept, you need to go back to part 1 of this series where I talk about big O notation. So what's the time complexity here? Well, in the best case scenario where our array is already sorted, we need a single pass. In the worst case scenario, the array is sorted in reverse order. Here we need n passes. Now, in each pass, we need n comparisons. Well, more accurately, n minus 1 comparisons. So if we have 4 items, we need 3 comparisons, right? So bubble sort runs in O of n or linear time in the best case scenario, and O of n squared or quadratic time in the worst case scenario. If you go to bigocheatsheet.com, you can see a visual representation of these growth rates. As you can see, O of n squared is very inefficient because it's in the red area. So this algorithm gets real slow as the amount of input data grows. Later, I will show you better sorting algorithms that run in the orange or yellow areas. But before we get there, let's implement bubble sort in code. So pause the video, spend 20 minutes and try to implement bubble sort on your own. Then come back see my implementation.